Could we turn the sun into a gigantic telescope? Paul Sutter reports, using a phenomenon known as gravitational lensing, it might be possible to use the sun as a gigantic telescope to peer deep into space. I'd like to know how that's going to happen. We have some incredible, powerful telescopes that have given us spectacular views of the cosmos and allowed us to look back to the early days of the universe. These observatories, such as the James Webb Space Telescope, are amazing feats of engineering that have required billions of dollars and decades of work. But what if we could access an even better telescope that already exists? This would not be a typical telescope. It would not even come with a lens, but it would be by far the most powerful telescope we would ever build. This telescope would use the sun itself. To give some perspective on how powerful the sun-based telescope could be, consider James Webb Space Telescope with a mirror that's 21.3 feet or 6.5 meters in diameter. James Webb is capable of achieving a resolution of around 1/10 of an arcsecond, which is about 600 times better than the human eye. At that resolution, the telescope could see the details of a coin placed 25 miles or 40 kilometers away from it, or pick up the pattern of a regulation soccer ball sitting 342 miles or 550 kilometers away. Another example is the Event Horizon Telescope, which is really a network of individual instruments scattered across the globe. By carefully coordinating its elements, the telescope has given us impressive images of the disks of gas surrounding giant black holes. To achieve that, it managed an impressive resolution of 20 microarcseconds, and at that resolution, the telescope could spot an orange sitting on the surface of the moon. Can you imagine? But what if we wanted to go even bigger? A large telescope would need either gigantic dishes or networks of antennae flying around the solar system, both of which would require an enormous leap into the technological capabilities. Thankfully, there just so happens to be a giant telescope already available, sitting right in the center of the solar system, that is the sun. While the sun may not look like a traditional lens or mirror, it has a lot of mass, and in Einstein's theory of general relativity, massive objects bend space-time around them. Any light that grazes the surface of the sun gets deflected, and instead of continuing in a straight line, heads towards a focal point together with all the other lights that graze the sun at the same time. Astronomers already use this effect, calling gravitational lensing, to study the most distant galaxies in the universe, and when light from those galaxies passes near a giant cluster of galaxies, the mass of that cluster amplifies and magnifies a background image, allowing us to see much farther than we normally could. The solar gravitational lens leads to an almost unbelievable high resolution. It's as if we had a telescope mirror the width of an entire sun. An instrument positioned in the correct focal point would be able to harness the gravitational warping of the sun's gravity to allow us to observe the distant universe with a jaw-dropping resolution of 10 feet by 10 arcseconds. That's roughly 1,000,000 times more powerful than the Event Horizon Telescope. Of course, there are challenges with using the solar gravitational lens as a natural telescope. The focal point of all this light bending sits 542 times greater than the distance between Earth and the Sun. It's 11 times the distance to Pluto and 3 times the distance achieved by humanity's most far-flung spacecraft, Voyager 1, which launched in 1977. So not only would we have to send a spacecraft farther than we ever have before, but it would have to have enough fuel to stay there and move around. The images created by the solar gravitational lens would be spread out over tens of kilometers of space, so the spacecraft would have to scan the entire field to build up a complete mosaic image. Plans to take advantage of the solar lens go back to the 1970s. Most recently, astronomers have proposed developing a fleet of small lightweight CubeSats that would deploy solar sails to accelerate them to 542 AU. 1 AU is the distance between the Sun and the Earth, which is about 93 million miles. Once they would have slowed down and coordinate their maneuvers, building up an image and sending the data back to Earth for processing. While it may seem outlandish, the concept is not too far from reality. And what would we get? With this kind of super telescope? If it were aimed at Proxima b, for example, the nearest known exoplanet, for example, it would deliver a 1-kilometer resolution. Considering that plans for successors to James Webb Space Telescope hope to achieve imaging capabilities of exoplanets where the entire planet sits in a handful of pixels, the solar gravitational lens puts those ideas to shame. It's capable of delivering an exquisite portrait of the detailed surface features of an exoplanet within 100 light years from us, let alone all the other astronomical observations it could achieve. To say this would be better than any known telescope is an understatement. It would be better than any telescope we could possibly build in any possible future for the next few hundred years. The telescope already exists, we just have to get a camera in the right position. This is originally from space.com, it's on Live Science. This is unbelievably fantastic. I hope they get to do this. Please leave your comments and thank you for your support. My Patreon account, the daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.